Alright class, today we're going to be talking about sum and difference identities. We're going to be able to use addition and subtraction identities to simplify statements. The sum and difference identities seem like fairly complicated formulas, but they really aren't. Notice, in every identity, we have an x and a y. X and a y, the x and the y are representing two different angles. And we apply those angles in the formula. It's important to note that the sign of x plus y is not just the sign of x plus the sign of y. It is certainly more complicated than that, as you can tell by the formula. To figure out the sign of x plus y, I have to do the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. And all of these formulas work in similar ways. Again, you don't have to have these memorized, but you do need to know how they work. And the important thing is that x and y are two different numbers that you need to apply to this situation. In the addition problems, the order might not necessarily matter because you're adding. But in the subtraction problems, make sure you're paying attention to where your x's and your y's go. The same thing with the cosine of x plus y. We have subtraction, so pay attention to which numbers you're plugging where. Here's an example of how we use these sum and difference formulas. I want to find the exact value of the sine of 75. Remember, when we use the exact value, we don't want a decimal. We don't want to put it in our calculator and get an approximation. Right now, the only angles that we know how to find exact values of are 30, 45, 60, and 90, and those angles that are in the other quadrants, such as 120 or 240 or 330. 75 is not a special angle. But we can apply the sum and difference identity here to represent 75 as a combination of two of these special angles. I can think of 75 as 30 plus 45. And again, I am not changing the problem here. 30 plus 45 is still 75. Now I just have to follow the formula. The sum identity for sine, I take the sine of x times the cosine of y plus the cosine of x times the sine of y. In this case, 30 is going to be my x angle, and 45 will be my y angle. So I have the sine of 30 times the cosine of 45 plus the sine of 45 times the cosine of 30. From here on out, I just have to evaluate each one of these trig functions. The sine of 30 is 1/2. The cosine of 45 is the square root of 2 over 2. The sine of 45 is the square root of 2 over 2. And the cosine of 30 is the square root of 3 over 2. Now this is just a simple adding and subtracting fractions problem. For the first fraction, I have the square root of 2 over 4. Whenever you're multiplying radicals, you multiply the numbers inside of them. So root 6 over 4. I technically cannot add together root 2 and root 6, but I can combine the fractions together to express my answer as the square root of 2 plus the square root of 6 over 4. And that is the exact value of the sine of 75. We can also apply this situation to radians. So why don't you give this one a try on your own? First, convert the angle into degrees, and then solve the rest of the problem from there, just like we did the previous example. You might also want to write down these two trig functions. These are the addition and subtraction identities for tangent. They are fairly complicated. Remember, you could also express the addition and subtraction identities for tangent as saying the sine of x plus y over the cosine of x plus y. You'll still end up with the same answers no matter what you do. Sometimes this way is a little bit shorter, though. We'll talk more about this in class. Make sure you write down any questions that you have.